Roller coaster. A roller coaster is one of the most iconic amusement park rides, built around high speeds, steep drops, and tight turns. While modern designs are carefully engineered for safety, the ride's long history includes several tragic accidents. Early wooden coasters in the early 1900s were especially risky because safety restraints and structural standards were far less advanced. Mechanical failures, poorly maintained tracks, and weak lap bars sometimes caused riders to be thrown from the train during sharp turns or sudden stops. These incidents led to stricter design rules, stronger restraints, and constant track inspections that are now standard across the industry. Drop tower. A drop tower lifts riders hundreds of feet into the air before releasing them in a sudden vertical fall. The thrill comes from the feeling of weightlessness as the ride plunges downward. Because of the height and speed involved, these rides must rely heavily on powerful braking systems and precise locking mechanisms. In rare cases, failures in the braking system or seat restraints have led to deadly accidents. Such incidents pushed manufacturers to introduce multiple redundant safety systems, including magnetic brakes and automated seat checks that prevent the ride from operating if a restraint is not fully secured. Ferris wheel. Ferris wheels appear slow and peaceful compared to other rides, yet their massive size can make mechanical problems extremely dangerous. The earliest Ferris wheels, from the late 1800s, were engineering marvels, but they were also experimental structures. Structural weaknesses, loose gondolas, and poor maintenance sometimes caused cabins to detach or the entire wheel to collapse. Modern Ferris wheels now undergo strict inspections and use advanced steel supports, but the ride's towering scale means that even a small failure can have serious consequences. Log flume. A log flume ride sends boats through winding water channels before dropping them down a steep chute into a splash pool. The danger historically came from boat collisions and sudden stops when water levels were not properly controlled. Riders could be injured or thrown forward if a boat hit another vessel or jammed in the channel. In earlier versions of the ride, poorly designed seat areas also made it easier for riders to slip out during the final drop. Today's flume rides use controlled water flow systems and sensors that space boats apart to prevent these dangerous situations. Swing ride. Swing rides lift chairs into the air and spin them around a central tower, causing the seats to swing outward in wide circles. Although the motion feels gentle, the forces on the chains and connections can be very strong. In the past, accidents occurred when chains broke or when seats detached due to metal fatigue or poor construction. Because riders are suspended high above the ground with minimal restraint, even a single mechanical failure could lead to a fatal fall. Modern swing rides now use reinforced chains, backup connectors, and strict weight limits to reduce these risks. Haunted house ride. Haunted house rides usually move slowly through dark indoor scenes filled with props and animatronics. Despite the slow speed, some deadly incidents in the past came from electrical fires or emergency exits that were poorly designed. In several historical cases, riders became trapped inside smoke-filled buildings when a fire broke out within the attraction. These tragedies changed how indoor rides are designed, leading to improved fire detection systems, flame-resistant materials, and clearly marked evacuation routes. Bumper cars. Bumper cars are designed around controlled collisions where riders steer small electric vehicles and crash into one another. While the impacts are meant to be harmless, older versions of the ride sometimes caused injuries when seatbelts were absent or when vehicles accelerated too quickly. Electrical floor systems and exposed wiring also posed risks if poorly maintained.
Over time, the ride evolved with padded interiors, speed limits, and improved electrical safety that keeps the playful crashes from becoming dangerous. Pendulum ride. Pendulum rides swing a large platform of riders back and forth like a giant clock. The arc grows higher and higher until riders experience powerful forces at the top of the swing. The scale of these rides means that structural stress on the arms and support towers is enormous. Rare accidents have happened when mechanical joints failed or when restraint systems malfunctioned while the ride was at its highest point. Because of this, modern pendulum rides include heavy-duty steel supports, redundant locking restraints, and real-time monitoring systems that detect unusual movement before a failure occurs. Water slide. Large water slides send riders racing through twisting tubes and steep drops at high speeds. The combination of water, speed, and sharp turns can become dangerous if the slide design is flawed. In some cases, riders have been thrown from rafts or lifted off the slide surface due to excessive speed or sudden bumps in the track. One widely reported incident involved a very tall slide where the raft briefly became airborne, leading to a tragic outcome. After such events, stricter design guidelines were introduced to ensure that slides maintain safe speeds and stable rider positions. Spinning ride. Spinning rides rotate rapidly while also moving riders in unpredictable directions. The constant spinning can create strong centrifugal forces that press riders against their seats. In earlier designs, restraints were sometimes too simple, allowing riders to slip out when the spinning became intense. Mechanical breakdowns in the rotation system also posed risks if parts failed while the ride was at full speed. Over time, stronger harnesses and improved mechanical designs have greatly reduced these dangers while preserving the ride's chaotic motion. Observation tower. Observation towers slowly lift passengers high above the park to provide panoramic views. The ride is usually calm, but the height involved makes structural integrity extremely important. In rare historical cases, elevator systems or cables failed, causing cabins to drop suddenly. These events led to the adoption of multiple braking systems, backup cables, and strict inspection procedures. Modern observation towers now operate with safety standards similar to high-rise elevators. Looping ride. Looping rides send riders through full vertical circles, turning them completely upside down before returning them upright. The engineering behind these rides must carefully balance speed and shape so that riders remain safely pressed into their seats throughout the loop. In the early days of amusement park experimentation, some loops were built as simple circular shapes, which created extreme forces that injured riders. A few poorly designed versions even caused fatalities. Later, engineers introduced the teardrop-shaped loop, which spreads the forces more evenly and became the standard for modern looping attractions.